So today we're going to be talking about how you graph inequalities in two variables. So real quick, we're going to review how we graph lines. And so I have a line up here. What form is this?
Slope-intercept.
Slope-intercept form. Very good. Okay. What is the slope in this problem?
M.
M. What is the y-intercept?
X.
B. B. So those two things, once again, are review. Okay, you should already know those. And now what we're going to do is we're going to look at how you graph an inequality. And so notice in our very first problem it says to graph 3x minus y is less than 2. So what I need to do is put this in slope-intercept form. What's the very first thing you do?
Move your 3x.
Move your 3x. Yep. You can move your 3x over. So now I have negative y is less than negative 3x plus 2. Now how do you solve that? Or how do you put this in slope-intercept form now? Divide by negative 1. Now what's the important thing since I've got an inequality?
Switch the.
I need to switch the inequality. So since I divided by that negative 1, so I'm left with y is greater than 3x minus 2. Now that wasn't the only way we could have solved it. We could have added y to start with and then subtracted 2. Now looking at that, what is my slope?
3.
3. So my slope is 3. What is my y-intercept?
Negative 2.
Negative 2. So I'm going to come over to my graph, and I'm going to put a dot at negative 2. Slope of 3 means you do what?
Up 3 over
Up
1.
3 over 1. Up 3 over 1. Now when we're graphing inequalities, before you draw a line through it, okay, these are inequalities. And so real quick, if you remember with inequalities, we had an open circle and a closed circle when we used a number line, right? Now I've got a coordinate plane. And so in a coordinate plane, we kind of have something like that. We have a dashed line, and we have a solid line. You will use the dashed line when there is no equal to part to your problem. You will use a solid line when there is an equal to part. So is there an equal to part in this problem?
No.
No. Basically, the equal to part would have this. It would look like that. Okay, it would have the underline. It doesn't have that. So I'm going to use a dashed line. Okay, so what I need to do is I need to go ahead and get a dashed line and draw that in. And so we're going to be looking at, let's try that again. Oh my goodness, we're having a hard time there. Let's try that one again.
These days.
Okay, now we'll try it.
You told me.
There we go. So now when we had the number line, we had a way to shade. We either shaded to the left or to the right. Now what we need to do is figure out, do we shade in region 1 right here, or do we shade in region 2? So this is what you need to do. You need to pick a point on one side of the line or the other. Doesn't matter what point. I'm going to give you a hint. It's usually good to use one with a 0. So I'm actually going to pick 0, 0. So I'm picking a point on one side of the line or the other. I'm going to plug that into my inequality. So I'm going to plug 0 for x and 0 for y. When I solve that, I get 0 is greater than what number?
Negative 2.
Is that a true statement? Is 0 bigger than negative 2?
Yes.
So that means the side with 0, 0 is correct. And I'm going to shade on that side. So with your colored pencils, that's why I left colored pencils on, you can go ahead and shade in.
That's all red.
All blue.
And so our answer is going to be this. You will never shade on both sides of the line. It's always going to be one side of the line or the other. So once again, so that you understand, you will only shade on one side of the line or the other. So that's our first problem we looked at.
It should have been arch.
So we're going to go ahead and we're going to look at the next problem as well. And so if you notice, we've got 4 problems we're going to go through. So if things are still a little unclear, hopefully by the 4th they'll make a little bit more sense.
Hopefully.
So let's go ahead and look at the second one. Oh, skipped it. Go back. There we go. This one says y is greater than 1/2 x plus 3. Now this one's nice because this one is already in slope-intercept form. What's my slope?
1/2.
My slope is 1/2.
All right.
What is my y-intercept?
3.
3. So I'm going to start by putting a dot where?
On the 3.
At 3. A slope of 1/2 means you do what, folks?
Down 1 over 2.
It means you do what,
Up
folks?
1 over 2.
Yep.
Up 1 over 2. Up 1 over 2. Now, what type of line am I going to use here? A dashed line. So let's go ahead and put a dashed line in. When everybody gets to this point, I'll go ahead and continue.
And you know the luckiest one of all.
If it's like a greater.
Santa.
Oh, it's greater than, yes.
Need some more.
All right, so let's go ahead and I have two regions, two areas. I have the area above here that I'm going to call region 1, and I have the area here, which is region 2. So I'm going to pick one point. Can't be on the line, has to be on one side of the line or the other. 0, 0 works out well again, so I can plug in the point 0, 0. I'm going to plug in 0 for both x and y. When I do that, I get 0 is greater than what number?
3.
3. Is that a true statement?
No.
No, so I don't want to shade here with the 0, 0. So which way am I going to shade?
The other side.
I'm going to shade region 1. Very good. So there you go.
I get you.
So if it's false, you shade the opposite one.
If it's false, you shade the other side.
Okay.
What if,
So far, so good?
what if
Not
the,
too bad. This is all we're doing today.
what if the line happens to be on the origin?
Then you pick a point on one side or the other.
Can we practice all
And it
day?
has to be on the x-axis?
No assignment.
No, it doesn't have to. Let's look at this one. X minus 1 is greater than y. Is that in slope-intercept form?
No.
No.
If you
Yes,
flip it around, it
is.
is. Yes, it
Well, it's in
is.
slope-intercept form. Okay. If you are confused, you
Oh my
could write
gosh,
it this
it is.
way,
It is.
and that's the same thing. Okay. What's your slope?
1.
1. What's your y-intercept?
-1.
-1. Very good. And so, where do I start? -1. A slope of 1 means you do what? Up 1 over 1.
Told you.
What type of line do you use?
Dash.
A dash.
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 Dashed, dotted, same thing.
Please say the right names, Lynn. You are really calling.
Okay, I have two areas. I have the area above and the area below. What point do you want to use?
0, 0.
0, 0 again will work fine. So let's plug in 0 and 0. So when I plug 0 and 0, and I could have plugged it into the top equation too, doesn't matter. I end up getting 0 less than what number?
-1.
Is
That a
0 less
false
than
statement.
-1? So which way am I going to shade 1 or 2?
2.
2.
Because it's false.
Because it's false.
False accusations.
There you go.
Can we use colored pencils on the test?
Yes, you can.
Aaron still calls right.
Now, the reason why we're going to use colored pencils is because eventually, and it probably won't be this year, we will get to where you have two equations, and you shade, yes, use two different colors, and it's the area that is shaded by both colors. And then eventually, we'll even get to 3 equations, and we'll talk about where those are story problems. Okay, something called linear programming.
Let's just stick with
So, anyway, it actually is, and we'll use them with the graphing calculators as well. So, okay.
We have to be DT slave.
Let's look at the very last one then. Oh, that very last one, wow.
Oh, that's
So
easy.
remember what we said. We need to put this in slope-intercept form, very first step. So what do you need to do?
Minus 2x.
Minus 2x. Does anybody know what form this was in originally?
This is
Standard, very good. What do you do now?
Divide by 3.
Divide by 3. Do you have to flip the inequality?
No.
No, because it was a positive 3. what?
6.
6. Okay. Slope is
Negative
negative 2/3. Y-intercept is
6.
6. Okay, so y-intercept of 6. 5, 6, that's where I start. Okay. What's the slope of negative 2/3?
Down 2 over 2.
Down 2 over
3.
3.
Down 2 over 3.
Solid or dashed line?
Solid.
Solid line, for those of you that didn't catch it, there is an equal to part right here. Okay, in the problem, it's right here. So since there's an equal to part, you're going to have to use a solid line for this one. Okay, solid line. So solid line will put me right, here. Okay, oops, I'm a little off on that one, but that's okay. So I have two regions. Okay, I have region 1 and I have region 2. So let's pick a point.
0, 0.
Okay, plug in 0 here, 0 here, and you get 0 is what?
Greater than or equal to 6.
Oops, greater than or equal to 6. Oops, is that true? Is 0 bigger than 6? So which region am I going to shade, 1 or 2? 1. Good. Now that's all you're going to be doing today, folks. Shading.
I love shading.
So very first assignment for today, tomorrow I've got a worksheet for you. Okay? Today is on page 320, 12 through 23. If you would like graph paper, it's always located in my top drawer on the right side. Now before I let you go on your assignment, I've got a short quiz. Okay, so first of all, tomorrow your assignment is going to be page 320, 12 through 23. So not too hard, you should be able to zip through that fairly quick. I've got a short quiz and then we will check your assignments.